Alright, hi everyone. This is Algebra section 10, completing the square. In this video, I'll give an overview of the topic, I'll then go through the worksheet, and then I will answer the questions that are on the worksheet. The description box below gives a link to my Instagram page. Head over there if you want to see images of the worksheet that's shown in this video, as well as the answer sheet to take screenshots or copy from, things like that. Right, so completing the square. This is quite linked to factorising quadratics. I'll leave a link to that video down below. In that video I said, we factorise a quadratic so that we can solve it, so that we can draw it on a graph. Completing this square is quite similar. It tells us something about how the quadratic looks on a graph, but it tells us something a little different to what factorising would tell us. Factorising a quadratic tells us where the quadratic crosses the x-axis. It's really good for that. Completing the square tells us about turning points, or maximum or minimums, as some people know them as. Right, what is a turning point? I like to think of turning points as the point in which, if you were drawing the graph, you would stop drawing up and you would start drawing down. And similar, you would stop drawing down and start drawing up. It's the turning point of your pencil. Like, I'm going up, I'm going up, I'm going up. Oh, I'm about to go down, turning point. Oh, I'm going down. That's the maximum. Again, oh, I'm drawing down, I'm drawing down. I think I'll draw up now. Oh, turning point. That's your minimum. These are turning points. And what completing the square tells us, it tells us the coordinates at which these turning points or these maximum and minimums occur. I'm quite new to YouTube still. I haven't created any videos on graphs, but I will be doing. Therefore, apologies if this doesn't make sense and there isn't a video of mine to go reference. There are plenty out there. Like, you could search turning points, maximum and minimums on YouTube and you'll find a brilliant video. I don't have one yet, but I will do one. But for the meantime, what we're going to do in this video is we're just going to learn how to complete the square. You don't have to actually know anything about turning points or maximum minimums. I just like to give a little context as to why sometimes we're doing stuff. I find I hated it in school when, like, they were teaching me something. I was like, what's the point? Why do I even need to know this? Am I just telling you this because I want to make your life dull? No, I'm telling you it because one day you might have to draw a graph in an exam and they might say, what is the turning point of this quadratic? And you're like, geez, god damn it, what is it? And I'm saying, remember, completing the square tells you about turning points. Therefore, if a question asks you something like that, you probably need to complete the square. So anyway, enough of that. Let's get into how to complete the square.
Alright, this is the worksheet for Algebra section 10, completing the square. This subject, I think, gets a lot of bad rep for being hard, but I think that's because of some of the methods that are taught. They can have too many steps. This method has always worked for me and it's super streamlined. You only need to remember 2 rules. If you have a quadratic, it will look like this, where A, B and C are usually numbers. The completed square form of this quadratic looks like this, again where A, M and N are usually numbers. In order to get from this quadratic to this completed square, you just need to remember the equations for getting from these letters, A, B and C, to these letters, A, M and N. Let's go over them. The first rule is that easy. I haven't even written it down. It just says that capital A is equal to capital A. That is, this number here, capital A, will always be this number here, capital A. So you can just go ahead and copy these numbers when you have this quadratic and you want to get it in completed square form. This number here will always go here in the completed square form. The first proper rule is M is equal to B over 2A. So in this rule here, M is this M here, B is this B here, and then A is this A here. So M is equal to B divided by 2 times by A. The second and final rule is this. N is equal to C minus AM squared. This N here is this number there. This C is this number in the quadratic. A we already know, it's here. And M we've just worked out. So we already know M. Therefore, we can work out N. Let's go through some examples and you'll see how easy this topic is. So, example 1. This question is asking us to complete the square. We have a quadratic here, and it's in this form here. And the question is asking us to complete the square, i.e. we need to get this quadratic in this form here. We know the rules for completing the square, so I'd say we've got this all sorted, so let's get into it. Again, like I said, this quadratic here is in the form of this quadratic here, where A is equal to 1, B is equal to 4, and C is equal to 7. That's the first step, writing these out. Next step, we want to get our quadratic in this form here. We know from our rules how to find A, M, and N. So let's go ahead and do that. As I've said, A is always equal to capital A, which is 1. So this A will be 1, because the number in front of this x squared is 1. Next, from our rules, M is equal to B over 2 times by capital A. We know what B is. It's 4, because we have a 4 in front of this x. And we know what capital A is, because we've just worked it out, it's 1. Therefore, M is equal to 4 over 2 times 1. 4 divided by 2 is 2. Therefore, M is equal to 2. And our last rule, N, this is to find this number here. We know that N is equal to C minus capital A times by M squared. Well, C, we've written here, is this number from the original quadratic. It's 7. We know what A is. We found it here. Capital A is equal to little a, which is 1. And we've just worked out what M is. M is 2 here. Therefore, N is equal to 7 minus 1 times 2 squared, i.e. N is equal to 7 minus 2 squared, which is 7 minus 4, which is equal to 3. Therefore, we have everything we need to write our quadratic in the completed square form. If A is 1, M is 2, and N is 3, then our quadratic in the completed square form is this. We have bracketed x plus 2 squared plus 3. I bang on about this all the time, but it's a really good habit to get into. Let's check our answer. If we expand the brackets in our completed square expression, we should get back to our original quadratic, this guy here. That's how we know we've got to a correct answer. So let's check that. Here, I've taken the completed square, I've expanded the brackets, and yes, I get back to the original quadratic. Therefore, we know our answer is correct. Let's look at the second example. Once again, we have a quadratic in the usual form, and we've been asked to put it in the completed square form. The only difference between this example and the one that we just did is here we have a number in front of the x squared term that isn't 1. So instead of a 1 being here, we now have a 3. But it's fine. There's nothing new that happens because there's a 3 there. We just carry on as usual. Right, first things first, let's note down what our coefficients are, or the numbers in front of the x terms, and what our constant is. So here, A is equal to 3, B is equal to 12, and C is equal to minus 5. That's the first step done. Right, second step, time to refer to the rules for completing the square. We do this to find little a, M, and N. So here we go. Little a is equal to capital A, which is 3. M is equal to B over 2a. We know B is 12, and we know A is 3. Therefore, we get 12 divided by 2 times 3, which is 12 divided by 6, which is 2. So M is 2. And finally N. N is equal to C minus A times by M squared. C is equal to minus 5. A we found is 3. And M squared we've just calculated. We know M is 2. So M squared must be 4. Therefore N is equal to minus 5 minus... Sometimes it's good to put these in brackets because you need to deal with this A M squared first. And then we'll deal with the C and minus section last. So minus 5 minus bracketed 3 times by 2 squared, which is 3 times by 4, which gives 12. So this becomes minus 5 minus 12, which is equal to minus 17. Once again, we have everything we need to write our quadratic in the completed square form. If A is 3, M is 2, and N is minus 17, then our completed square form looks like this here. We have 3 times by bracketed x plus 2 to the power of 2 minus 17. And here I go again. It's time to just check that I haven't made a mistake. I've taken the completed square form, I've expanded the brackets, and the expression that I get to is the original quadratic, i.e. this here is equal to this. Therefore, I know the completed square that we got is correct. Final example now. Nothing different with this question compared to the previous two, except we do have a square root chucked in here to catch you off guard, but it won't because nothing is different As long as you know the steps, we can just carry on as normal. Let's do the first step, and that is writing out the coefficients and constant that are in our original quadratic. So we have capital A is 4, B is 4 root 4, and C is -5. Next, let's find the A, M and N that are in the completed square form. So we know A, M and N. Therefore, we can write out our completed square form, which is here. We've got 4 times by bracketed x plus square root of 4 over 2, all squared, -13. And here is me doing a check as usual to make sure I haven't messed up. All looks good, therefore our answer is correct. See, nothing to worry about even if a square root was thrown in there. I think maths loves to look all complicated and sinister sometimes, but it's just a mask. As long as you remember the method or rules of how things are done, it doesn't matter how shady the expressions look, you'll be fine. Alright, now is a good point to pause the video and try out the questions here. You can then come back to this video to see the workings and compare them to your own, or you can just head straight over to my Instagram page. The link is in the description box below to see an image of the final answers that correspond to these questions.